In this video, I will show you how to do some basic polynomial operations. We will add, subtract, and multiply, as well as get into some basic factoring. We'll start off with factoring out the GCF, and then we'll talk about the difference of squares pattern. Problem 1a is an addition problem, and when you're adding, all you're doing is combining like terms. So looking for like terms, let's see, I see like terms here and here. Also, the constants are like terms. So -3 and -4 are like terms. The other two have no like terms. Now, we have to write our answer in standard form, so the higher exponents have to go first. So we need to start with 4x to the third power. The next highest exponent is squared, so I'll just bring that down plus 2x squared. Now combining 5x and 1x makes 6x. Combining -3 and -4 make -7. So that's the answer. Now sliding over to problem number 1, part B. Okay, I think I'll just put a little 1 here to show everybody that this is problem number 1, part B. This is a subtraction problem. There's one additional step that we have to do. Put a 1 right here and think of it as a -1. We need to distribute the -1 throughout the second set of parentheses. So if we do that, then we're going to have -2x squared minus x plus 4. It just changes all the signs. The first set of parentheses will just come down unchanged. So I'm just going to bring down the 4x to the third power plus 5x minus 3. After that, we're back to combining like terms again. So again, these are like terms here and here, and these are like terms here and here. So just like before, we have to do the highest exponents first. So 4x to the third power, and then minus 2x squared. Combining 5x and -1x makes 4x. And combining -3 and +4 makes +1. So that's the answer to problem number 1b. Number 2a is a multiplication problem. Since we just have a monomial, we are going to do the distributive property. So I'm going to take my -2x to the fifth power and multiply it by x to the fourth power. That's going to make -2x to the ninth power. Notice that when you multiply variables, you add those exponents. Next, I'm going to multiply -2 times -3, and that's going to make -6. But I'm also multiplying x to the fifth power times x squared, which makes x to the seventh power. 2b is also a multiplication problem. However, we have a binomial times a binomial. So we're going to still do the distributive property, but we're going to do the distributive property twice. So first I'm going to distribute this 5x. So 5x times 2x squared is going to make 10x to the third power. And now 5x times 3x is going to make 15x squared. So next I need to distribute this -2. So -2 times 2x is going to be -4x squared. Notice how I line up my like terms. These are like terms. And then I will have -2 times 3x, which will make -6x. Finally, I will combine my like terms. No like terms here, so this will be 10x to the third power. If I combine these, that's going to be positive 11x squared, and then I'll just bring down the -6x for the final answer. Number 3a is another subtraction problem. So when I see this subtraction, what I'm going to do is I'm going to put a 1 here, which really is a negative 1. And I'm going to take that negative 1 and I'm going to distribute it across the parentheses. So that is going to give me negative 5x squared plus 2x minus 4. Nothing is in front of the other set of parentheses, so the 5x plus 4 just comes down unchanged. Please do not bring down any parentheses. Once you do the distributive property, there are no more parentheses. That makes it more clear that now we are combining like terms. So let's see. We have like terms here, and we have like terms here and here. Be careful to keep your exponents in descending order. You want the highest exponents first. So I see x squared, which had no like term. So I'm going to write that first, negative 5x squared. That's the highest exponent. Next comes the x terms. 5x and 2x will make 7x. So I'm going to have plus 7x. And interesting, positive 4 and negative 4, they cancel out completely. So I will write down nothing. So this is the final answer for 3A. 3B is another multiplication problem. Here we have a binomial times a binomial. So these are the ones where we do the distributive property twice. But you know what? There's another way to do it. That's called the box method. So I think I might show the box method this time. So the box method works like this. Alright, the box method of multiplication. Alright, a binomial times a binomial. So you take the first binomial and put it down one side. So here I have 8x to the third power, and then I have negative 3. Now I'll take the other binomial and put it across the top. So here I have 2x to the third power and minus 4. And then you find the product of each one of these. Okay, so if I multiply these two together, that's going to give me 16x to the 6th power. Remember, when you multiply with variables, you add the exponents. For this square, I need to multiply 8x to the third power times negative 4. So that's going to give me negative 32x to the third power. Okay, for this square, I need to multiply negative 3 times 2x to the third power. So that's going to give me negative 6x to the third power. And then the last square, that would come from negative 3 times negative 4. So that's going to be positive 12. Okay, so these four terms really are the answer. However, I need to watch out for any like terms that I need to combine. Do you see any like terms? Sure. X to the third power and x to the third power. These are like terms. So when I write my answer out in order, I'm going to combine these. But the highest exponent is x to the 6th power. So we'll begin with 16x to the 6th power. Now putting these two together makes negative 38x to the third power. And then I'm going to bring down the plus 12. So this should be the final answer. Okay, 3C is a multiplication problem, but since all we have is a monomial, then I'm just going to do the distributive property. So that's going to give me, well, let's see. 6 times 2 is 12. X times x is x squared. And then we have the y squared. Okay, so that's what I get when I multiply the monomial times 2x. Now I'm multiplying the monomial times 3y. Well, 6 times 3 is 18. There are no other x's, so I'm just going to keep my 1x. And then y squared times y is y to the third power. So boom, there's the answer to 3C. Alright, I see this big old plus sign here. That means this is an addition problem. And for addition problems, all you do is combine like terms. So these are like terms right here, and these are like terms right here. So that's all we're doing. Okay, the highest exponent is squared, and it has no like term, so I'm just going to bring down that 7x squared. Now, 6x and negative 6x, that's 0x. In other words, they cancel each other out, and I write nothing. Meanwhile, 5 and 1 make 6. So that's the answer to 3D. Alright, for number 4, we have a rectangle, and we're told that the width is 4x minus 3, and the length is 2x plus 5 feet. And then we're supposed to find the perimeter in standard form and the area in standard form. Alright, let's start with the perimeter, and let's draw a picture. So the width is 4x minus 3. So here's 4x minus 3. And then they said that the length was 2x plus 5. So the length is 2x plus 5. You know what, just for fun, because I know we're going to need this same picture again for the area, I think I'm going to go ahead and copy it over. So it'll be waiting for us. Okay, anyway, perimeter. So how do I find perimeter of any shape? I add up all the sides. So I need expressions for the other sides. Well, of course, both of these sides of the rectangle are the same. So we will have another 2x plus 5 up here. And the width is the same over here. So this side is also 4x minus 3. So I need to add up all the sides. Now I don't need to rewrite this so that all of the terms are in a row. I just understand that if I add all of these expressions, I'm combining like terms. So the like terms are 4x and 2x and 4x and 2x. So 4 and 4 make 8, and then 2 and 2 make 4. 8 plus 4 is 12. So altogether I have 12 x's. So 12x. Now look at the constants, because these are all like terms. 5 plus 5 is 10. Negative 3 and negative 3 make negative 6. Positive 10 and negative 6 is 4. So this is going to make plus 4. So this should be a nice expression for the perimeter. Alright, now it's time to do area. But how do we do area? How do we find the area of a rectangle? Well, we multiply base times height, or length times width, however you want to say it. We need to multiply 2x plus 5 times 4x minus 3. And when you multiply, you either do the distributive property twice, or you can use the box method. I think for this problem, I'm going to go back to the double distributive property way of thinking about it. So if I do 2x times 4x, that's going to give me 8x squared. And then if I have 2x times negative 3, that'll be negative 6x. Okay. Then I'm going to distribute the 5 now. So 5 times 4x is going to be 20x. And then 5 times negative 3 is going to make negative 15. So, of course, I have like terms right here. So I'm going to end up combining those. So bringing down the 8x squared. Combining these, I should have positive 14x. And then bringing down the minus 15. So this should be an expression for the area. Alright, number 5, we need to factor out the GCF, or greatest common factor. So I see the 8 and the 24. Both of these are divisible by 8. So I'm going to take out the 8 and put it out front. However, now I look at the variables. Both terms have a's. The smaller amount of a's is a single a, so that's how many I pull out. Now they both have b's. The lesser amount is b squared. So that's my GCF. Now I'm going to have parentheses, you understand. Alright, but to figure out what goes inside the parentheses, I need to divide by my GCF of 8ab squared. 8ab squared. So if I do that, the 8's cancel out. One of the a's will cancel out. So that's going to leave a. Two of the b's will cancel out, but that will leave ab. Minus. Okay, 24 divided by 8 is 3. And then the a's and the b squares cancel each other out. So this is the final answer. Now, a common mistake is to pull out a number that is a common factor but not the greatest common factor. So I just want to show this to you one time. Let's say that you accidentally thought that 4 was the greatest common factor. So let's say instead of pulling out 8ab squared, you only pulled out 4ab squared. Okay, imagine that happened. So in that case, you're doing 8 divided by 4. So you're going to get 2ab. And now you're doing 24 divided by 4, so you're going to get 6. So you would get this. How would you be able to recognize that you made a mistake? Well, if you look inside of the parentheses and you notice that these numbers are still divisible by something. In this case, they're both divisible by 2. So that lets you know that you need to keep going. So you don't have to erase the problem and start over. You need to say to yourself, wait, these both can be divided by 2. So what I'm going to do is I will divide them by 2, and then I'm going to take that GCF of 2 and put it out in the front. So then when you redo the problem, this is multiplication. So 2 times 4 is 8. So this becomes 8ab squared. And then now that you've divided by 2, the 2's cancel out and you get ab minus 3. Of course, notice that this is the same thing that we got when we did it properly the first time. But I wanted to show you how you can, first of all, notice that you didn't pull out a big enough number and then fix it without starting over. Alright, in 5b, we're still trying to do a GCF. So, 3, 2, and 4, these numbers are not divisible by anything other than 1. So, forget about that. But look at the variables. Every term has a variable, so there's definitely going to be a GCF with variables. What's the smallest amount? X. So that's going to be the GCF. Except for one thing. Notice that the first term has a negative sign. Whenever that happens, you're going to have a negative GCF. So instead of factoring out an x, you're going to factor out negative x. Now, we're going to have parentheses, and we're going to have stuff left behind. But to figure out what gets left behind, you divide by your GCF. So once you do this division, you know, a negative divided by a negative is a positive. So this will be positive 3. This x cancels out one of the x's, so I will have 1 less x. Negative divided by a negative is a positive, so this will be positive 2x squared. And this will be negative 4. The x's cancel out. So this is the final answer. For problem number 6a, we are supposed to factor using the difference of squares pattern. So the difference of squares pattern works like this. We're going to take each term, which is a perfect square, and we're going to divide it evenly. So x to the 10th power is the same thing as x to the 5th power times x to the 5th power. There will be a positive and there will be a negative in this pattern. And then 49 can be written as 7 times 7. So that's how you factor using the difference of squares pattern. We can do the same thing for 6b. Doesn't matter that there's a 9 in front. We can still use this difference of squares pattern. Alright, everything will be split up evenly. So 9 is 3 times 3. Y squared is y times y. Then we will have 1 plus and 1 minus, and then 16 is 4 times 4. So there's your difference of squares pattern. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.